morning children. Welcome back once again to my maths class. So children, in today's video lesson we are going to deal the part 3 of the polynomials. And those who have not watched the previous videos of part 1 and part 2 of polynomials, do watch them completely, get the concepts and proceed to this video. So children, maths is a beautiful subject. Learning maths is a wonderful experience and makes you a successful person. So I'm here for you to help you out to get acquainted with mathematics. So children, let's get started with the polynomials part 3. So today we are going to talk and discuss about the relationship between the zeros and the coefficients of the polynomials. It is quite interesting and very important for the examination part. So let's have some recap, okay? The zeros, what are the zeros? Zeros are the value of x, the value of x at which the polynomial comes to 0, okay? The value when applied to the polynomial, if the value of the polynomial comes to 0, that value is called as a 0, right? Now when we are coming to the coefficients, now we are going to establish a relationship between the zeros and the coefficients, okay? What are the coefficients? Let us take the example of the linear polynomial. Ax plus b, and a condition, an important condition, that a must not be equal to 0. So this is a linear polynomial, okay? And what are the coefficient here? Only a. Coefficient is the number attached to the variable. Variable here is x and the constant is b, right? This is the constant. Here this is the coefficient. Now when we take the example of a quadratic polynomial, see here, ax square plus bx plus c, the constant is c, right? Whereas the coefficients are a and b. The coefficient of x variable, the coefficient of x square variable, right? Now, if you take the example of the general form of a cubic polynomial, ax cube plus bx square plus cx plus d. Here also condition a not equal to 0. Here also a not equal to 0 is a condition, okay? Now here the coefficients are a, b and also c, okay? Because it is attached to the variable. Here variable x square, here x cube, here x. So a, b, c are the coefficients here. And whereas the variable free d is the constant, right? Constant is a number which is variable free, right? These are the coefficients, this is the constant, and we are going to establish a relation between zeros and the coefficients today. Now, to establish a relation, let me first take the case of linear polynomial, okay? First we will discuss linear polynomial, then we will go for the quadratic and then the cubic. Here. What is the linear polynomial general form? P of x is equal to ax plus b, where a is not equal to 0. This is the general form. Here the coefficient is a and the constant is b. So to know the relationship, I'll be taking example of, I'll be taking a simple example. Let me take 2x plus 3, right? This is a linear polynomial. Here the coefficient is 2 and the constant is 3. Now to get 0 of this polynomial, now we know what is a 0. To get a 0 of this polynomial, first we have to equate it to 0. Which when applied, the polynomial comes to 0, isn't it? So first we have to equate it to 0. Now what is the 0 here? 3 goes to the other side, minus 3 by 2. So this is the 0 of this polynomial. That we know in the part 2 we have studied how to find the zeros. Okay. Now this is the 0. Now how we got this? this 0 is the 0 of the polynomial. Okay, how we got this? Now let's see. Here x is equal to minus 3. See, minus 3, that means minus 3 here is the constant. Here constant. Compare it with the general form. Okay, 3 here is the constant term. Okay, constant term by 2. 2 here is the coefficient. Okay, coefficient of what? Coefficient of x. Okay, I'll write a short form, coefficient of x. So this is the relationship between the 0 and the coefficients. Right. Here x is equal to, how I got it? From the example itself I am telling you. I have deduced here minus 3. So minus 3 is the constant term and 2 is the coefficient of x. Also here if you write like this, okay, so I got minus 3 is what here, when you compare it the general form, b, right, upon, what is 2 here? 2 is the coefficient, that is a, right. So this is the relationship between the 0 and the coefficients of the polynomial. So you may ask me that, is this relationship, you may get a doubt that, is this relationship between the zeros and the coefficients applicable for all the linear polynomials? Yes, it is applicable for all the linear polynomials. I'll be explaining you one variation. Okay, let me take one. Now we have taken 2x plus 3. So let me take px equal to 2x minus 3. Right? So when you compare it with the general form, ax plus b. So what is a to b is minus 3. Right? See, when you compare it, 2x plus of minus 3. So b value is minus 3. Now here, if you want to find out the relation, so our 0 is minus b by a. So minus b is already having minus 3, minus b by a. So simply minus of minus plus 3 by 2. This is the 0 of this polynomial, 2x minus 3. Or else, if you in some terms, you may not remember minus b by a, but you have to remember that it is minus constant term by the coefficient of x. So here again, minus constant term by the coefficient of x. That comes to 3 by 2. Right. Now let me take another example. A different variation. Okay. Minus 2x minus 3. Let the polynomial be minus 2x minus 3. Now here a value is minus 2 when compared to the general form. Now b value is minus 3. So our 0 is equal to minus of b by a, isn't it? So minus b is already minus 3 by a is minus 2. So we get minus 3 by 2. Cancel the minus up and down, you get minus 3 by 2. Or if you also see minus of the constant term by the coefficient of the x, see, it comes to minus 3 by 2. So children, this is an established relationship between the 0 and the coefficients. Now let's see the relationship in the quadratic polynomial. So we'll take the case of a quadratic polynomial. Let's write the general form of quadratic polynomial, ax square plus bx plus c, where a must not be equal to 0. Right. Now in this case, if you see here, it is having the degree. How much degree? The degree of the polynomial is the highest power of the variable. So degree 2. That means at most, at the maximum, we can have 2 zeros, right? So 2 zeros at most. Right? That means in maximum we can have two zeros. So let those zeros, I will suppose them as, let the zeros, let alpha, the Greek letters alpha and beta be the two zeros of the polynomial. Right? Polynomial here is our quadratic polynomial. I'll suppose them as alpha and beta with the Greek letters. So now to establish a relationship between the zeros and the coefficients, we are going to take the help of sum of the zeros. Okay, sum of the zeros. That means here alpha plus beta, sum of the zeros given minus b upon a. Okay, this is minus b upon a. Now minus b is what here? B is the coefficient of x, isn't it? So coefficient of x upon, and what is a here? A is the coefficient of the x square variable. Coefficient of x square variable. So this is the relationship established. Okay. We'll be verifying it using an example. Okay. Let's write down here. Now again, product of zeros. I'll do the multiplication of the zeros. Okay. Here the zeros are alpha and beta. The product of the zeros given as c by a. Okay. There is no minus here. Just c by a. Now c by a. What is c here? The constant term. The constant term by a is the coefficient of x square. Coefficient of x square. So this is the formula. Now this we need to remember. Now we will be verifying it using one example. Okay. This alpha plus beta minus b by a, and alpha beta, the product is c by a. So we will take an example which is there in your textbook. Okay. The example of 2x square, the p of x given 2x square minus 6x plus 6. Okay. I think minus 8x. Right. Let me see textbook. So it is minus 8x, right, plus 6. This is example problem. Solving this, I will be proving these two relationships. Okay. Now here we know how to split the middle term using the factors. Now the factors here, factors of 6 and 2, product of these two, that is 12x square. So the factors of 12 I'll take, so that if you add them you have to get 8. So the splitting of middle term that you have learnt in your 8th class. Okay. Minus 6x minus 2x, let me take. So if you add them, it is minus 8. If you do the product, 6 into 2, 12 x square, minus into minus plus. So I'll take these two factors. Now in these two, what is the common? 2x. So x minus 3 is left over, and in these two, minus 2, if you take, x minus 3 is the common. Okay, this is an equal to 0. This is a quadratic equation equal to 0. I am finding out the zeros, that is the factors of x. Okay, here now in these two terms, x minus 3 is the common. I'll take it out, and the leftover is 2x minus 2 equal to 0. That means x minus 3 equal to 0, 2x minus 2 equal to 0. Implies x minus 3 equal to 0. So x equal to, if you send this value other side, it becomes 3. Implies 2x minus 2 equals to 0. That means x is equal to 2 by 2. That comes to 1. Okay, that means I've got the zeros 3 and 1. So what we assume those zeros in the quadratic, let them be alpha and beta. So here alpha is equal to 3 and beta is equal to 1. Okay, I've got the two zeros. Now Let me verify. Now what is alpha plus beta? Here, we'll see here alpha plus beta. Just adding the zeros. So 3 plus 1. Okay. Now the relation is minus b by a. So what is here b? Let me equate to the general form. Bx square bx plus c. So this is the general form. Now tell me what is a there. A is 2, b is minus 8, c is 6. Okay. 2 minus 8 and c is 6. These are ABC. Okay. Now here we got minus b by a. So minus of minus 8. Minus of minus 8 by a is 2. Right. Now this comes to minus minus plus. 2 ones, 2, 4. So this comes to 4. Here also 4. Again, let me see. Minus coefficient of x. Minus coefficient of x is minus 8 by coefficient of x square. Coefficient of x square is 2. Right. So this all comes to here. 3 plus 1, 4. Here, if you cancel, you get 4. Here, you get 4. So, we have proved the relationship. So, and also we will see for the product here. Now, the product alpha into beta. So, 3 into 1. Right. Here. And c by a. C is 6. 6 by a is 2. And constant term by coefficient of x square. The constant term is 6. Coefficient of x square is 2. Okay. This comes to 3 equals to 3 equals to 3. So, we have proved that the coefficients or the sum of the zeros and the product of the zeros are minus b by a and c by a. That is minus coefficient of x by coefficient of x square and constant term by coefficient of x square. Okay children, quickly pause the video and note down the notes and we'll go for the cubic polynomial. Now cubic polynomial, the general form ax cube plus bx square plus cx plus d, where a is not equal to 0. So in the cubic polynomial, at most we can have 3 zeros, right? At the maximum we can have only 3 zeros. The degree is 3 and we can have 3 zeros. So let me suppose those zeros as alpha, the Greek letters beta and gamma. Okay. These are the 3 zeros of p of x. Right. Of this cubic polynomial. Let the zeros are alpha, beta and gamma. Now I will establish a relation between the zeros and the coefficient. Then I will be verifying it using the example problem of your textbook. Now here, as we have in the case of quadratic, we will take the sum of the zeros. The sum of the zeros always, remember, they are minus b by a. Whatever polynomial it is, whether it is linear, quadratic or cubic, it is minus b by a. Now we will write the general form here for minus b by a. Here b is little bit changed, right? B is the coefficient of x square. So minus coefficient of x square. Okay. And a is the coefficient of x cube. Coefficient of x cube. So this is the relationship. Okay. And also, after the sum, we will also be having the product alpha, beta and gamma. That is d minus of d by a. Okay. D is the constant. Right. Here, that means minus of d is the constant term by a is the coefficient of x cube. Coefficient of x cube. So this is the product, relationship between the product of zeros and the coefficients of the polynomial. Now, apart from these two, we have another relationship, that is the sum of the products taken twice at a time. So, alpha beta, beta gamma plus first alpha, beta, beta gamma, and gamma and alpha. So, the sum of the product of the zeros taken twice at a time. So, this is a special one regarding the cubic polynomial. The relationship here, it is minus, no, not minus, it is just c by a, children. So, remember, for the addition, for the product of the sum of the zeros, c by a, and for the product here there is minus here, there is no minus here. Okay, don't get confused here. And c is, what is c? The coefficient of x, and a is the coefficient of x cube, right? Now, if you feel difficult in remembering them, right, don't get puzzled up. See, you have to remember few concepts by correlating with the quadratic polynomial, by correlating with the same concepts of the previous one. Like, we have for the quadratic polynomial, alpha plus beta equal to minus b by a, and the product is equal to c by a. So, remembering them and correlating with them, you have to remember these. Don't get confused. Don't by heart the formulae. Okay. Now, we need to remember this also, coefficient, all this, because if the polynomial is not in the form of a, b and c, let the polynomial be px cube plus qx square plus rx plus s, so on. So, then there are no a, b and c. So, do not remember this a, b and c, but you should remember the coefficient of x, or like this. So, here if I want the sum of the zeros minus the coefficient of x square cube by coefficient of x cube. So, p. So, this comes to minus q by p, not minus b by a. So, you have to remember the main thing here by correlating with quadratic and the linear polynomial. You can remember it quickly and fast. Okay. Now, I will prove this, like I will be validating these formulae using a textbook problem. Okay. Let's see the textbook example of a cubic polynomial. P of x is equal to 2x cube, here given, minus 5x square minus 14x plus 8. Okay, minus 5x square minus 14x plus 8. This is a cubic polynomial given in your textbook as an example problem. Now, here we have to equate it to the general form first. Remember, in the general form we have only the additions, cx plus d. So, here a is equal to 2, b is equal to minus 5, c equal to minus 14, d equal to 8. First, write down the coefficients and the constant, seeing the general form. Now, we will find the sum of the zeros here. I'll take it here only, alpha plus beta plus gamma. Now, here also given, all the three zeros given in your textbook are 4 given zeros are, right, 4 minus 2 and half. Okay, these are the given zeros for the polynomial p of x, right, here. That means the alpha is 4, beta is minus 2 and gamma is half. Now, the sum of the zeros, that means here 4 plus beta is 2 minus 2 plus half. Okay, plus or minus, written it as minus, right? Here, if you see, again minus b by a. So, b is minus, again b is minus b by a is 2, and minus of coefficient of x square, minus of coefficient of x square. coefficient of x square is minus 5 here by coefficient of x cube. Coefficient of x cube is just 2. Okay. Here, if you simplify using the like the LCM, if you take, you will get 5 by 2. Here also plus and minus into minus, plus 5 by 2 plus 5. Check it out, children. Here, this is the LCM part. LCM you do, you get 5 by 2, 5 by 2 and 5 by 2. So it is hence verified. Now let's see the next one. Alpha beta, beta gamma and gamma alpha. This is the sum of the product of the zeros taken twice at a time. Okay. Now let me take here alpha beta. What is alpha here? 4 into beta is minus 2 and plus beta gamma. Beta is minus 2 into 1 by 2. Okay. Plus gamma into alpha 1 by 2 into 4. So we'll do the product first. Minus 8. Okay. 2 gets cancelled. So minus 1 and 2 twice. So plus 2. So it comes to minus 9 plus 2. So that is minus 7. This part I've done. Okay. That is C by A. So let's see. Is it C by A? What is our C? Minus 14 by A is 2. So this comes to 7. Minus 7. Right. And also let us check equal to minus coefficient of x. Coefficient of x is minus coefficient of x by coefficient of x cube. So 2. So minus into minus again. Minus coefficient of x. See here the coefficient of x is 14. Minus into minus. You got it. Right? Here one second. So sorry children. Here remember we don't have minus here. See just we have coefficient of x. Coefficient of x is minus 14 by the coefficient of x cube, that is 2. So this comes to minus 7. Here there is no minus. I'm sorry. Here there is minus. Here there is minus. And remember, like correlating, you remember where you have to put minus. Both are minus. Here there is no minus. Whereas in the quadratic you have minus here. And for the product we don't have minus. Like that, by correlating you can easily remember the formulae. Okay. Now the last one, the product here. Product how we do? Alpha into beta into gamma. 4 into minus 2 into 1 by 2. So multiplication. So 2 gets cancelled. So it comes to minus 4. Right. Now minus d by a. Okay. Minus d. What is d here? 8. 8 by a is 2. So it comes to again minus 4. Now minus of constant term by the coefficient of x cube. Minus of the constant term by the coefficient of x cube. So all this comes to minus 4 and minus 4. Hence we have proved this relationship. So like this we have the relationship established between the zeros and the coefficients of the polynomials. So children, in these three cases, learn the concept perfectly, and those who have not watched the part 1 and part 2 of the polynomials, do watch them and proceed to this video. Completely watch the video, get the concepts and practice the problems. Now, I'll be looking forward in our next video lesson with the exercise problems. Thank you all.